Okay, so as promised, we're going to look at this problem. So just to remind ourselves, the question that we're dealing with is right here. How do the root mean squared speeds of argon atoms and the nitrogen molecules compare at the point of thermal equilibrium? All right. So now that I've solved the problem with the writing tablet here, I've written here the molar masses or the atomic masses or the molecular masses of um, argon and nitrogen. They're right here, okay? Argon is 39.95 AMU. Nitrogen, which is, of course, a diatomic molecule, its molar or molecular mass is 28.02 AMU. Now, if these two gases are in thermal equilibrium with each other, what that means also is that their kinetic energies are equal. So therefore, if you can find the kinetic energy of this and this and set them equal to each other, then that would help us to determine the root mean squared speed. So how does that happen? Well, the kinetic energy of each of these, let's start off with the argon. Kinetic energy is equal to half m of argon, the molar mass or the molecular mass of argon, times the velocity squared of argon, based on the formula that we discussed earlier. And similarly, the kinetic energy of nitrogen would be equal to half of the mass of the nitrogen molecule times the velocity of the nitrogen molecule. So if we set these two equal to each other, you're going to have half m of argon times velocity of argon squared equals to half mass of nitrogen times velocity of nitrogen squared, right? Which means that we can cancel out the half here and here. And then if we divide both sides by, let's do mass of nitrogen and velocity of argon squared. So mass of nitrogen times velocity of argon squared. This is going to cancel here and here, and the mass of nitrogen is going to cancel here and here. And what are we left with? We're left with the molar mass of argon divided by the molecular mass of nitrogen equal to, now, as we said before, the molecular mass or the atomic mass of nitrogen is 39.95 AMU divided by the molecular mass of nitrogen, which is 28.02 AMU. So let me work this out on my calculator. 39.995 divided by 28.02. Okay, so according to my calculations, rounded off to 4 sig figs, this will be equal to 1.426, all right? So basically, this will be equal to the velocity of nitrogen squared divided by the velocity of argon squared. And therefore, we can rewrite this as velocity of nitrogen squared equals to 1.426 times the velocity of argon squared. So let me just continue up here. So therefore, the velocity of nitrogen would be equal to the square root of 1.426 times the velocity of argon. So square root of that is equal to, according to my calculations, 1.19 velocity of argon. So basically, what this is saying is that at the point of thermal equilibrium, the velocity of nitrogen will be equal to 1.19 times that of argon. All right, so that basically is an answer to the question, how do the root mean squared speed of argon atoms and the nitrogen molecules compare? Well, that's the answer right here. Right here is the answer. The root mean squared speed of nitrogen will be equal to 1.19 times that of argon. All right. Okay.